Today we're on Unit 12, Lesson 6, Mixed Probabilities. We'll be covering pages 429 to 431, so we're covering 3 pages. I'll be using colored pens because when we're testing for independence, there's more than one way you can test for independence. So I'll show those different ways using different colors. So you don't have to have different colored pen or pencil, that's up to you. Calculator for our adding, subtracting, multiplying, dividing, and your homework is going to be the 3 pages 432 to 434. The nice thing about today's lesson is really it's a summary. So first, starting off with our formulas, for any event A, the probability of not A is equal to 1 minus the probability of A. So let's just use some symbols here. My symbol for not is the tilde symbol. So the probability of not A is equal to 1 minus the probability of A. For any two events, A and B, the probability of A given B is equal to the probability of A and B divided by the probability of B. So we know that our symbol for given is this vertical segment, so the probability of A given B is equal to the probability of A and B, which is this symbol, over the probability of B. Events A and B are independent if and only if the probability of A and B is equal to the probability of A times the probability of B. That's one test for independence. Or if the probability of A given B is equal to the probability of A. And the one that we haven't, that isn't in here in the formula summary, we haven't used in a little while, is, I'll just put it up here, is remember the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. So our first exercise, given that the probability of event B occurring, given event A has occurred, is the probability of B given A equals the probability of A and B divided by the probability of A. Answer the following. Rewrite this formula solving for the probability of A and B. So in other words, we have this formula here, and we want to get the probability of A and B by itself. Well, right now we have the probability of A and B divided by the probability of A. So undo the division by multiplying both sides by the probability of A. So that these would divide out. And we'll have the probability of A times the probability of B given A is equal to the probability of A and B. And I can just switch that around, writing the probability of A and B on the left-hand side. How could we write this formula if events A and B are independent? Well, if A and B are independent, then the probability of B given A would equal the probability of B. So let's take and replace the probability of B given A here with what it's equal to, the probability of B. That's as long as events A and B are independent, which we are assuming they are. So the probability of A and B is equal to the probability of A times the probability of B. Exercise number 2, the results of a survey of the student body at Kingston High School about television viewing preferences are shown. Are the events student is a female and student prefers reality series independent of each other? Well, in order to test this for independence, we could do one of three things. Independent if the probability of female given prefers reality series equals the probability of female, or the probability prefers reality series given they are female equals the probability of reality series, or the probability of female and prefers reality series equals the probability of female times the probability of reality series. So using F for female and R for reality series. So again, to determine whether or not these are independent of each other, we can test one of these three. You don't have to do all three, just one of them. But of course here I'm going to show all three. Okay, so independent if probability of female given reality equals probability of female. So probability of female given reality. So we're given reality, so we're looking at this here. And the total is 180. So 180 is our denominator. And of those 180, 110 are female. So the question is the probability of female given reality, which is 110 over 180, equal to the probability of female? So you went 110 over 180. Now for female, the total is 260 over the total number of students surveyed, 490. Go to the calculator. 110 divided by 180 is 0.61 repeating. Does that equal 260 divided by 490? I'm going to see is approximately 0.53. So no. They are not independent of each other. Or we could have tested asking, is the probability prefers reality given female equal to the probability prefers reality? So reality given female, the denominator is the female. So I'm looking at just this here. The total female is 260. And out of those 260, 110 was reality. And the probability of reality, so I went 110 over 260. Does that equal Reality is 180 for the total over the total number of students, 490. And calculator, 110 divided by 260, approximately 0.42. And 180 divided by 490, approximately 0.37. No. Yeah, and so whatever independence one we choose, yeah, we're going to get different decimals because we have different probabilities that we're comparing, but still the decimals that result or the probabilities that result are not going to be equal for any one of these three. Okay, and then the last one, probability of female and reality. Does that equal probability of female times probability of reality? So female and reality, that's 110 over 490. Does that equal probability of females 260 over 490 times probability of reality is 180 over 490. $110 divided by 490, 0.2245 approximately, and 260 over 490 times 180 over 490 is 0.1949 approximately, so no. Okay, so exercise number 3, the results of a poll of 200 students are shown in the table for this group of students. And do these data suggest that gender and preferred music styles are independent of each other? Justify your answer. All right, so we have female, male, techno, rap, and country. So we have here, we have more than 3 that we can actually work with. We could go, oh, all right, so are they independent? Is the probability of female given country equal to the probability of female? Is the probability of male given techno equal to the probability of male? So there's many different ways we can do this. Because we're talking about the gender and the preferred music style. At least up in number 2, we wanted to really just check whether the student, given the student was a female and reality series. So we're just looking at female and reality series. Here it's gender, which there's 2 different we could choose from, and 3 different music styles. So guess I'll go with independent if I'll go with probability of female given techno equals probability of female. Or if I stay along that, probability of techno given female, does that equal probability of techno? Or I could go with something totally different. Probability of male given rap, does that equal the probability of male? Or, yeah, there's many more ways in this case. All right, but I'm only going to do one. Probability of female given techno, does that equal probability of female? So female given techno. So given techno, we're looking at this. So one thing you want to note here is we don't have totals. So we need our total column here. Um, 54 and 36 is 90. And I might as well just add these up. That's 65. And this is 45. That's 110 and 90. So this is 200, as it should be. So probability of female given techno, that's equal to the probability of female and techno over probability of techno. Probability of female, don't have that. 54, 25, and 27, 106. Let me just double check. 76 and 18, 94. Okay. So female and techno. So we know that that's 54 out of 90. Does that equal probability of female, which is 106 over 200? (54) divided by 90, 0.6. 106 divided by 200, 0.53. So no, they are not independent events. Exercise number 4, a credit card company states that 42% of its customers are classified as long-term card holders. So 42% long-term, 35% pay their bills in full each month. Say in full. 23% are long-term card holders who also pay their bills in full each month. Let the event that a randomly selected customer is a long-term card holder be L. And the event that a randomly selected customer pays his or her bill in full each month, F. So the 23% is L and F. What are the values of the probability of L, the probability of F, and the probability of L and F? So the probability of L is equal to 0.42. The probability of F, 0.35. And the probability of L and F, 0.23. Draw a Venn diagram and label it with the probabilities from part A. So we have our two circles. One is labeled L, the other one F. The overlapping regions 0.23. Lollipop stick for L is 0.42. Lollipop stick for F is 0.35. So with that, I'll kind of fill in the rest here, or as much as I can. If all of L is 0.42 and this piece of it is 0.23, then if I take 0.42 minus 0.23. That leaves me with 0.19 for that portion. And if all of f is 0.35 and this portion's 0.23, then 0.35 minus 0.23 would leave us with this portion here, which is 0.12. And if we add these all up, 0.2, 0.31 and 0.23 is 0.54. All right, so if this is 0.54, then outside here would be 1 minus 0.54 outside the two circles, which is 0.46. Now, certainly if you prefer a table, right, I'll show you that, because you don't always have to use a Venn diagram. Yes, it said to draw a Venn diagram here, but let's say instead, for our table, we'll have long-term, not long-term, total, paid in full, not paid in full, total. So long-term would be 0.42, would go here. Paid in full, 0.35 here. And long-term and paid in full, so 0.23 would go here. And then the lower right-hand corner here is 1.0. And we can just fill in the rest. 2.3 plus 0.12 would bring us to 0.35. 0.35 plus 0.65 would bring us to 1.0. 0.23 plus what gets us to 0.42. It's going to be 0.19. 0.42 plus what brings us to 1.0. 0.58. And 0.19 plus what brings us to 0.65. 44? 46. 0.46. Right, let me just double check. Yep, that adds to 0.35. This adds to 0.42. This adds to 0.58. Okay, everything looks good. Use the conditional probability formula to calculate the probability of L given F. So if I'm looking for the probability of L given F, that's going to equal the probability of L and F, or the probability of F. So if the denominator is all of circle F, 0.35, and the numerator is the and, 0.23. Go to the calculator, 0.23 divided by 0.35, 0.657, rounding to the nearest thousandth. Tenths, hundred thousandths is 3 places. 0.657. If I'm looking at the table, right, and I want the probability of L given F, so the given F, so we're looking at just the female, looking at this here, and the total there is 0.35, that's our denominator, and the L and F is the 0.23. D, use the conditional probability formula to calculate the probability of F given L. Okay, L is going to be the denominator. So all of circle L is 0.42, and F and L 0.23. 0.23 divided by 0.42, 0.5476, which rounds to 0.548, which is greater the probability of F given L or probability of F. Okay, so F given L is our 0.458, 0.548. I think I transposed some digits there. The probability of F is 0.35. So the probability of F given L is greater than the probability of F. Well, this tells us that long-term card holders are more likely to pay their bill in full each month. Than a general customer. Remember, the two events A and B are said to be independent if the probability of A given B equals the probability of A. Are the events F and L independent? Independent if the probability of F given L equals the probability of F. The probability of F given L is our 0.548, and the probability of F was our 0.35. No, they were not independent. On our last page, exercise number 5. Suppose that a credit card company states when a customer is selected at random, the probability that the customer has his or her bill paid in full each month is 0.35. The probability that the customer makes regular online purchases is 0.83. And these two events are independent. Okay, so we're told that these two events are independent. What is the probability that a randomly selected customer pays his or her bill in full each month and makes regular online purchases? Well, when they're independent, in general, the probability of A and B is equal to the probability of A times the probability of B. So in this case, the probability that they pay in full each month and make regular online purchases, we'll say P for, no, I'll use O for online purchases, would equal the probability pay in full times the probability regular online purchases. So 0.35 times 0.83. Maybe I'll just put these in parentheses instead of having the multiplication symbol there. All right, so 0.35 times 0.83, 0.2905. That's the probability. Exercise 6, a student is chosen at random from the student body at a given high school. The probability that the student selects math as the favorite subject is 1/4. The probability that the student chosen is a junior, so we have math is 1/4. Junior is 1/16 over 459. If the probability that the student selected is a junior or that the student chooses math as their favorite subject is 47, so the or here, so junior or math, is 47 over 108. What is the exact probability that the student selected is a junior whose favorite subject is math? Okay, so I don't think a good Venn diagram or a table, two-way frequency table, is a good setup for this because of the different denominators, all the different denominators we have here for our probabilities. So I think the best thing to do is just to try a formula, right? We want to find the probability that the student selected is a junior whose favorite subject is math. So that means we're looking for probability of junior and math as favorite subject. That's what we want to find. Okay, we have or, we have the probability of or, we have the probability of math, and we have the probability of junior. So this is where we want to use, in this case, the probability of junior or math. So I'm using the formula. Our formula for the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. So using these letters, the probability of junior or math is equal to the probability of junior plus the probability of math minus the probability of junior and math. Now, if I want, before I can make the substitutions, all right, I can put the 47 over 108 here, 116 over 459 here, 1/4 here, and leave that as minus J and M. Or I can get this by itself first if I wanted, all right? So in doing that, I would add this to that side and subtract this from this side. So basically what I would do is I'm adding this and also subtracting this from the left side. So I have, this has gone over to this side, and this has been added over to this side. So we end up with the probability of J and M is equal to probability of J plus probability of M minus probability of J or M. Right, this went out. This was a subtraction, so I added it. So that's out. Added it to both sides. And now here, we subtracted. So it's out here on this side, but it's been subtracted. Now it's on the right-hand side. Okay, so now if I put in the fractions, 1/16 over 459 plus 1/4 minus 47 over 108. I'm just going to have to bring it down into the next area, I guess, and go to the calculator. 1/16 over 459 plus 1/4 plus, nope, minus 47 over 108. And if I math frac that, 31 over 459. Or I'll go with 3 decimal places, 0.068. So that's exercise number 6. It's part A. Are the events the student is a junior and the student's favorite subject is math independent of each other? Explain your answer. All right, well, let's see. Since I just found that, I'm going to use it. So independent if the probability of junior and math is equal to the probability of junior times the probability of math. So is 0.068 equal to junior was 1/16 over 459 times math was 1/4. 1/16 over 459 times 1/4. This is 0.06318 something. So 0.068. Does that equal 0.063? No. They are not independent. Another long video, I apologize. But we did the 3 problems, rather the 3 pages, but again, when you're testing for independence, you only need to do 1. You don't have to do all the ones that I worked out, okay? So when you work on the homework, it will not take you as long as this video took us. Thank you once again.